All right, here we go, ladies and gentlemen. This is going to be M7, lesson 6-8. And in this particular lesson, we're going to be looking at the percent of change. Okay, I really like this lesson. It's probably my favorite in this whole chapter or this unit for a couple of reasons. First of all, percent of change is a really, really important concept in the financial world. And it is a really great tool to show how things change over time. So what I'm going to do is I'm going to go ahead and show you a way I would use this as a teacher to look at you guys, okay? So one of the things you know, especially in this math class, is I keep a lot of statistics on how you perform on tests, right? So every time Mackenzie takes a test, and every question she's ever answered, I have in a database, and it tells me which subjects she's doing well in, what subjects she struggles in, what subjects she's aced, what subjects that are showing repeated patterns, okay? And I do that for all of you, okay? But it also shows me where she's improved from the beginning of the year. Ideas that maybe she didn't do so well on, and now she's doing great, or ideas that somehow have been lost. She did great on them, and then it's like, what happened? Okay? Hasn't happened, just so you know, okay? It hasn't happened. No, hey, we'll talk about you later. So let's say that on the first couple of tests, Mackenzie's averaging about an 83%, okay? Okay, but then let's say that now she's averaging about 97s, okay? So this was what we would say, we call this the original amount. And we would call this next part the second or final amount. And then there's actually going to be a third spot, and we're going to call this the amount of change, okay? That's going to be an important part here, amount of change. All right, so the final amount is a 97. What is the difference between 97 and 83? How much has that changed? What would we say? Has it gone up or down? Okay, so we would say it's been an increase. So for that kind of thing, we put a plus because that means positive. It's a positive increase. Anytime something goes up, we say that's a positive thing. It's an increase. Okay, but how much? Caitlin. Yep, it's gone up. So the percent change is a plus 14. And yes, in this particular instance, it's percent. Okay, plus 14%. Okay? But do we always see things as percents? No. Maybe what I want to do is look at how my income has changed. Okay, what kind of percent increase did I see this year? Sometimes we get bonuses or pay raises, things like that. And in order to balance our budget and figure out how much to save, we save certain percentages. Or you guys will be tithing at some point. Usually, how many you tithe? How much? Anyone know? Tithe. To tithe, put money in the offering plate.
Oh, like 20 bucks my mom does, and your mom does 10%.
Yeah, 10%. Nice job, Hannah Harvey. Typically, we kind of learn that 10% is the best way to go. So, needless to say, we have to look at, we can use this in other ways, okay? So, it's not always going to be in percents. Maybe the original amount is maybe I am making $200 a week. And I go up to $250 a week. Is that a plus or minus in Gretchen? It's a plus. And by how much? It's a plus $50 a week. No. I'm just building some numbers here. I'll show you how we're going to use it in just a minute. But I think you'll find that it's very easy. Okay. All right, next example. Let's say that well, actually, I'll give you some real numbers. I was paying about $1,090 a month to live in my house in Michigan. Okay?
What did you work as?
A teacher. It was a big chunk of money, right? Because Michigan, where I lived, it was very expensive. Okay? Here in Fort Wayne, my house cost me $700 a month. Is this an increase or a decrease? Gretchen? It's a decrease by, does anyone want to take a guess? Hannah? Yep, it's a minus $390. Okay, I'm going to put a little dollar symbol there, but it's a minus $390. That's a great decrease, let me tell you. Okay, because it's a lot cheaper to live here in Fort Wayne than it is in Metro Detroit. Yeah.
Well, that's about what we pay. Your old price.
Mm-hmm. Some houses are really expensive, some are not. Mrs. Bornheimer and I, we like to have a smaller mortgage just because if something were ever to happen to one of our jobs, we could still, it's one of those things that we'd like to be able to keep our house.
Do you own your house?
Well, we're homeowners, but we're paying a mortgage, which means that in so many years we'll own it. We're considered homeowners, but yeah, mortgages is very much like a rent to own. You pay the bank money over the course, you're paying them back. But in theory, what's happened is you borrowed a huge chunk of money, you bought the house, and now you got to pay that money back to the bank.
That's what we do.
That's called a mortgage. Yep.
How big's your house? Like a 2-story or?
It's a 2-story. Yeah. It's got almost a 3/4 of an acre. It's got a big barn and a garage and a basement, and it's nice.
And you live by the mall?
Yep. Okay, so shh. Let's stop. Stop. Jackson. Thank you. All right, here's how we're going to use these 3 pieces of information. In your book, if you look at page 310, they give us an equation to help us think about how things change. Okay? So, here's how this works. You take the amount of change and you put it over the what? Anyone know? What's it say there? Gabby? Yeah, the original amount. And that equals the percent of change. No, I think I'm running out of space here. Let me rewrite. Over what? Yeah, Gabby? Yeah, because percents are always over 100. See how that kind of keeps coming back into play here? So the first one we're not going to touch because that's already got percents. But let's look at that $200 one. What parts would go where here? Okay, what parts would go where? Caitlin?
50 would go over 200.
Okay, so 50 would go, so the amount, yep, it'd be a positive 50 over 200. And that equals, do we know the percent of change? No, that's what we're trying to find. So it's going to be x over 100. Can you guys solve this? Yeah, I think so. What would we do? Gretchen? 50 times 100. Yep, you're right. What's your question? Because no, the reason we don't look at the final amount is because it requires some more math, okay? What we're looking at is purely the change. Did it go up or did it go down compared to the original amount, okay? So in theory, yeah, we did use the final amount, right? Because that's how we found this. So we use these 2 pieces of information to find this. And then we use this and this in our equation to find the percent. So every problem is really 2 steps. You look at the 2 numbers here to find change. And then you use the change to find the percent of change. Real quick, hands down. I will give you a chance here in just a second. An example of this would be, sometimes we hear people say, the market did really well today. It went up 2%. Or gas is doing really well. Gas prices nationwide are down 3%. Or, hey, I took a 5% pay cut. Or, hey, grocery bill needs to go up 10%, or etc. So you see what I'm saying? We use percent change all the time, okay? And this is how we find it or use it, is in these kinds of situations. We'll look at a couple more examples, but let's figure this out. If I had a positive $50 increase from $200, what percent change is that, Parker? All right, I want to finish this math problem, and then we'll do questions. Maybe. Yes. Yes. Yeah, divide by 200, divide both sides by 200, and it equals 25? Okay, so I'm going to do a little bit of erasing here, okay? I'm not going to go through all the math, but she explained it beautifully. X equals 25, which means that in this scenario right here, that represents a 25% increase in pay. Now, by the way, that's really unrealistic. Nobody gets a 25% increase in pay unless you work for a company and it's exploding in profits. Okay?
Will Apple ever get that?
No.
For their new phone?
I don't think so.
Maybe in Saudi Arabia.
Okay, I'm going to erase the stuff at the bottom here. I want to do one more example, then I'll take some questions. What about the decrease one? Okay, how would I set that one up? Izzy.
You would do 390.
Negative 390
over 1,090.
over 1,090 equals, do I know the percent of change, or is that what I'm trying to find? Okay, so what would I use?
X over 100.
Right. Go ahead and solve that with the person next to you.
Will you always have X over 100 for this tonight?
Not necessarily. We're going to look at a couple of examples from your book, okay? But typically speaking, that's most of the time how we use it, yes. Kind of like last night, we were always trying to find the part. It would be a negative percent because it's a decrease. Yes, very good. You got to take the negative into consideration in this one because it's a decrease. It's a decrease.
So we do 390 times 100.
Can you answer a question again?
Hang on. Okay, what did you come up with here? Hannah.
I got -36
Okay, so what this means is that when I moved to Fort Wayne, my mortgage went down 36%.
Is that good?
That means that's 36% of my income that goes back into my pocket. That's pretty great. Or 30%, I'm sorry, not 36% of my income. No. But a decrease of 36%, my mortgage got cut by a third. That's pretty amazing, okay? I love Fort Wayne.
Why was
All right.
it so expensive?
Just because, for a lot of reasons.
Somewhere like busy or big?
Not necessarily. I mean, busy, yes.
Wait.
It's kind of near the lake.
How do you know where his house
That would
is?
probably be fine, yeah. Okay, questions?
Jackson knows where your house is in
Yeah.
Michigan.
Questions?
Okay.
Parker?
So, can you do it like the other way? Like the multiplying cross, put a decimal two across way?
No.
Why?
Because in that one, we're not looking at change. We're just looking at parts and wholes. Here we're doing something entirely different. We're looking at how something changes. So you have to use this equation, wait for it, amount of change over the original amount equals the percent of change over 100.
So, is it always going to be that way?
Yeah, but why don't I show you an example, and if you still have questions, we can talk through it.
No. What I mean is it always going to be where the 100 is, where the percent
Yeah.
of change is?
Yep.
So, the percent of change is the X, right?
Right.
So, can you put an X over that? So I know.
No, because that's the percent of change, and your book's going to ask you for that percent of change, which is why it needs to be there. They're not going to ask you for X. You need to know to put the X in there. Okay? Right. However, Parker, sometimes they're going to ask you for the amount of change given the percent. So sometimes the X moves around. Why don't I show you 2 examples, okay? And then if you still have questions. All right. Let's go ahead and look at, actually, it depends on the instructions of the problem. Parker, if they ask you for the amount of change, where does the X go? And the amount of change. If they ask you for the original amount, where does the X go? And if they ask you for the percent of change, it goes where? Yeah, so you do know. You do know. Give yourself a little credit. Okay? All right. Take a look at page 313. Izzy, can I have you read a problem for us? Okay. Izzy's going to read to us problem number 23.
That's not part of our homework. $9 discounted to $4.
Okay. So, for all of these problems, here's how I recommend you set up your paper. Original amount, final amount, amount of change. I think that's definitely the easiest. Okay, so that's what I'm going to do. I'm going to do original amount, final amount, and I'm going to write this one out, of change. So for every problem, this is how I would set them up. I would do this. My personal, like if I were doing your homework, this is what I would do because this helps me see it. It's not confusing this way. So the original amount, $9. The final amount, $4. So then I got to ask myself, how did it change? Well, to go from 9 to 4, it has to go down how much?
It goes up.
So it goes down minus $5. Okay, then I use my equation, and I put the amount of change over the original amount, so -5 over 9 equals, and in this problem, the instructions read, find the percent discount. What they're asking you is to find the percent of change. If they ask you to find the percent markup, they're asking you to find the percent of change. How do you think markups and discounts differ? Anybody? Gabby. Right? Right. So how's that represented with symbols? You are totally right. Markups, the price goes up. Discounts, the price goes down. Okay, Savannah?
It will like
Oh, yes, she's right. It's either a positive or a negative. So in discounts, it goes down. It's a negative. Okay? If it's a markup, that's a positive. It goes up. So -5 equals x over 100. Okay, if I were to work this out, I get -500 equals 9x. Divide both sides by 9. And Mackenzie, what do you got? -56% equals x. So in this problem, number 23, the discount was 56%, or the object went down by a -56%.
this is easy. Can we just have a
It's not as easy for everyone, Jacob, but I'm glad that you feel that way. No, I'm really glad you feel that way. Gretchen? Because, Gretchen, that's a great question. Because the equation, wait for it, there it is. The equation does not call for the final amount. But in order to find the amount of change here, not the percent of change, but the amount of change, I need the final amount. Okay? The final amount never factors into your equation. No. But if you're not given a final amount, you can't do the math because you'll never then be able to find this part, the amount of change. Okay? So the final amount's really important, but it doesn't actually factor into our final equation. I'm glad you brought that up. That's a good point. Everyone benefited from that question. Okay, here's your homework.
It's right there. Can I guess it? It's up
Well,
there.
since it's already on the board,
It's right there.
Go ahead and guess it.
It's 1 through 7, 8 through 26 all. You said that you chose a problem
even.
that had
Not all.
I realize your homework is not going to ask you for anything like that.
Oh, then I
So, but next year it will.
Jacob, stop.
Don't stop, Jacob.
And let's go ahead and stop this recording.